Hey, what's up guys? This is video 4.6 talking about a new set of numbers today, complex numbers and imaginary numbers. So let's talk about first about number systems that we are familiar with. So in this table right here, or in this diagram, this picture, I have a list of numbers. So we're going to start here and work our way up. So let's talk about what natural numbers are. Natural numbers include, another word for natural numbers you could say are counting numbers. And they're called counting numbers because typically when you count, you start counting with 1, right? And that's where natural numbers start. Natural numbers start with 1, 2, 3, 4, and so on and so forth. These are your natural numbers. And that leads us to whole numbers. Whole numbers are natural numbers. Notice that as we go down, whole numbers are natural numbers, but whole numbers also include 0. So 0, 1, 2, 3, and so on and so forth. These are your whole numbers. Integers include whole numbers, which include natural numbers, but integers also include the negative numbers. So -2, -1, 0, 1, 2, like that. These are your integers. So they include whole numbers, natural numbers, but also include the set of negative numbers. Rational numbers include all of them, but rational numbers also include numbers that can be expressed as a ratio, okay, or as a fraction, in other words. So just to give some examples, so again, rational numbers include all of these numbers because whole numbers, integers, and natural numbers can be expressed as a ratio. You can write 1 as a fraction, right? You could say this is the same thing as 1 over 1. Same thing for 2. You could say 2 is 2 over 1. So all of these numbers can be expressed as ratios, which is why they are included in the set of rational numbers. But rational numbers also include numbers such as 1/2 or 1/3. They could also be numbers like 0.25 and 0.333, so on and so forth, like that. So these are rational numbers, and they can be negative as well. Now on the other hand, we have irrational numbers. So note that these are under real numbers. All of these that we're talking about, they're all considered as real numbers. However, rational numbers are not in the same set as irrational numbers and vice versa. An irrational number is a number that can't be expressed as a ratio. So it can't be expressed as a ratio. So for instance, we could say pi is an irrational number. Now if you were to punch pi into your calculator, or if you were to calculate pi, you should get something like 3.14 ... and it's a decimal with no occurring pattern or nothing repeating. It's just a random it's just a bunch of numbers that have no sort of pattern or repeatance. So pi is an irrational number. Square root of 2 is also an irrational number. If you were to punch this in, it would give you a similar type of a number. These are what we call irrational numbers. So again, these are all real numbers, and this is the number system that you're familiar with. And so far in chapter 4, we've been solving quadratics, and you might have noticed that anytime we've been solving for quadratics, it always says real solutions, looking for the real solutions. However, Today we're going to introduce to you a new set of number system, which is the imaginary numbers. Now, the imaginary numbers, we first need to define some terms, and that is first the imaginary unit I. The imaginary unit I is equal to the square root of -1. Now, just like how pi is equal to 3.14 dot 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 dot, I is also equal to a specific number. So I is not a variable. You can't treat I like you would treat a variable like x and y. They are not the same type of a number or variable, because x and y can be random numbers. It's just a random number that you can choose from, and you can substitute it for. I is not the case. I is a specific amount. When we talk about I, the unit I, we are saying that I is equal to the square root of -1. And this is what we call as an imaginary number. An imaginary number is, we call BI. Okay, BI is an imaginary number. So, as examples, I could have I. I could also have 2I, 3I, 4I, so on and so forth. So these are your imaginary numbers. Now, you can add real numbers with imaginary numbers. So I could take a random number like, let's say, 2, and add it to a complex number, add it to an imaginary number, and this is what we call a complex number. A complex number takes the form of a plus bi. This is the standard form for a complex number. And up here, you can see complex numbers consist of both real and imaginary numbers. Okay, now let's do some practice problems here. And let's want to show you how you can identify imaginary numbers or the imaginary unit. So here, for number 1, we have the square root of 49. And before, we have never touched the square root of negative numbers. We've had problems where we have negative square root of a number, but never have we had, so far, square root of negative number. This is what we do when we are faced with the square root of a negative number. I'm going to make a statement here and say that the square root of -49 is equivalent to the square root of -1 times by 49. And that's true, right? 49 is equivalent to, -49 is equivalent to -1 times 49. Now, using the product property of radicals, this is equal to the square root of -1 times by the square root of 49. Okay, well, I know that the square root of 49 is equal to 7. And the square root of -1 we have defined as the square root of -1 is equal to I. Square root of -1 is equal to I. So I have I times 7, or I can simply put this as 7I. 7 imaginary units is pretty much what I have here. 7 imaginary units, or 7I. And this right here is the square root of this this is the square root of -49. Now let's do it a couple more times. So for 2, you have the square root of -4. So the square root of -4 is equivalent to the square root of -1 times by 4. And using the product property of radicals, that's equivalent to the square root of -1 times by the square root of 4. Square root of -1 is the imaginary unit. I know that's equivalent to I. and the square root of 4 is 2. So I times 2, or I could say 2 times I. So 2I is the square root of negative 4. Now let's try 45. So I know that the square root of negative 45, again, I'm going to split this up to be equal to the square root of negative 1 times by 45, which is equivalent to the square root of negative 1 times by the square root of 45. Square root of negative 1 is equivalent to I. Square root of 45, now that this is positive, I can simplify it. I know square root of 45 is 9 times 5. So this is equivalent to I times the square root of 9 times the square root of 5. And this is equivalent to I times by 3 times by the square root of 5. And I'm going to write this in the form of 3I square root of 5. And I can really write this in any order that I want, because these are all being multiplied, and multiplication is commutative with these numbers. So there you go, that's simplified as much as you can get it. So for number 2, I have negative 2 times the square root of negative 100, and I'm going to write this as negative 1 times by 100, which is equivalent to negative 2 times the square root of negative 1 times the square root of 100. So negative 2 times by I, because the square root of negative 1 is I, and the square root of 100 is 10. Now remember that this is multiplication and it's commutative. So I can multiply this negative 2 and this 10 together. So it's negative 20I. Go ahead and try 5 and 6 on your own. Go ahead and pause that and give it a shot. I'm going to keep going though, and go to example number 3, where we're going to add and subtract complex numbers. Remember that complex numbers are A plus BI. So in this first box, let's write down A. So I have a complex number of 8 minus I. That is a complex number. And I'm adding another complex number, 5 plus 4I. So these are two complex numbers being added together. Now, adding and subtracting complex numbers is as simple as combining like terms. So here is a real number 8. Here is a real number 5. I can combine those together. So when I add them together, I get 13. Here I have an imaginary unit of negative 1. Here's an imaginary unit of positive 4. So when I add them together, I get 3i, because negative 1i plus 4i is 3i. And there you go. It's as simple as that. For B, I have a complex number of 7 minus 6i minus 3 minus 6i. Now the only thing here is, again, this operation is now subtracting rather than addition. Whenever I'm subtracting a complex number with another complex number, I have to remember to distribute this negative inside the complex number to the right. So I have 7 minus 6i, but now instead of having positive 3 here, it's being multiplied by negative. So I have minus 3, and then negative times by negative 6i would be positive 6i. So make sure that you remember to do that when subtracting complex numbers. Now I have a 7 and a negative 3 real numbers. Combine those together and I get 4. I have a negative 6i and a positive 6i here. Those will cancel out and be 0. So I'm just left with 4. So the difference between this complex number and this complex number is simply 4. Now let's do this last one, is C. I have 13 minus 2 plus 7i plus 5i. So this one's a little bit weird. I have this complex number in between this real number and this imaginary number. Now, you also notice that I'm subtracting this complex number. It's being subtracted. So I have to remember to distribute that through. So I have 13 minus 2 minus 7i plus 5i. Here are the two real numbers here, so 13 minus 2, which is 11, and I have minus 7i plus 5i, which would be minus 2i. And there you have it. That's as easy as adding and subtracting complex numbers can be. Now, to finish this off, let's talk about multiplying complex numbers. To multiply complex numbers, such as this one right here for a, I have an imaginary number outside here. And I'm multiplying it by a complex number, so negative 6 plus I. All I have to do is distribute that inside in order to multiply. So I have 4i times by negative 6. And then I have plus 4i times by I. So when I multiply these together, I can multiply the coefficients, because this is 4 times by I times by negative 6, and the order of multiplication does not matter because it's commutative with these numbers. So 4 times negative 6 is negative 24, and then I still have I. So now I have 4i times by I, which means I have 4i squared. I is being multiplied by itself. Now let's go back up to this first page and add on to some of our definitions. Now, what I'm going to do here to this equation is I'm going to multiply, or I'm going to square both sides. So when I do that, I have I, and I'm going to square it, and I'm going to square the right side as well, so I have square root of negative 1 squared. For the left side, this is just I squared. Now for the right side, remember that radicals undo exponents. Radicals undo exponents. So these are inverses of each other, which means they cancel. So all I'm left with is negative 1. So here we have a new definition. So while I is equal to the square root of negative 1, I squared is equal to negative 1. I is equal to the square root of negative 1. I squared is equal to negative 1. So let's go back down here, because I know what I squared is equal to now. So this is negative 24i plus 4, but I squared is equal to negative 1. Remember, square root of negative, So while I is equal to the square root of negative 1, I squared is equal to negative 1. So that's what we did here, is substitute I squared with negative 1, because they're equivalent. And now I have negative 24i minus 4, and this is a complex number, but we want to write the complex number in the standard form where the real number comes first, followed by the imaginary number. There you go. Now let's try B. So for B, we're going to use distribution, except we have two binomials here. So I have to take this 9 and multiply it by both. So I have 9 times by -4 plus 9 times by 7i. And then I have to take this -2 and multiply it by both. So I have -2i times by -4. And then I have -2i times by 7i. So 9 times by -4 is -36. And then we have 9 times by 7i, and that's equal to 63i. -2i times by -4 is +8i, and -2i times by 7i. So when I multiply the constants, I get -14, and when I multiply i's together, I get I times by I, which is I squared. Now let's see what we can combine here. So this is the only real number that I have. These two in the middle are imaginary numbers. So -36 plus 63 and 8 is equal to 71. So plus 71i. And then I have -14 I squared. And I squared is equal to -1. So I have my -36 plus 71i plus 14. Now I have a real number here and a real number here. So when I add them together, I get -22 plus 71i. And there you go. We just multiplied this complex number and this complex number together. Example 6 we will not be doing, so don't worry about that. But that should sum up everything from chapter or section 4.6.